Hello students, welcome back to our channel Diksha Karnataka. So as you know, we have started a series where we are discussing top 30 questions from all the important chapters. So in this video, I'll be discussing top 30 questions from one of the high weightage topic, that is amines. Okay, so you can easily expect 3 to 5 questions from this chapter. So if you are able to solve these questions, you can assure that this chapter is ready. So now let us see the first question. So we have first question is a reaction based question. So amines is a very small chapter, so focus on the preparation methods and the reactions, primary, secondary, the test that you have to focus. Okay, so first question here is, you have an RX, okay, any CH3CH2Br when it is treated with KCN, alcoholic KCN. So what will this do? This will change the Br to CH3CH2Cn, right? We'll get a cyanide group here. Now after getting this cyanide group, it is treated with LiAlH4, which is a reducing agent. So this one will reduce this to amine group. So this reaction you could have seen in the preparation method of amines. CH3, CH2, CH2, NH2. Now when you treat with nitric acid in case of aromatic amines converts the NH2 to OH group. So we will get here CH3, CH2, CH2, OH, right? So your option, the compound A will be this one where we have this cyanide group, then compound B is this one where we have this amide group, and then compound C is the alcohol. So we can see the first option is matching. This is Cn, this is NH2 group, and this is CH2OH. So the correct answer for this question is option number A. Okay, now next question, aniline does not undergo. So this is very important reasoning based question. We have this NH2. When we take Friedel-Crafts reaction, we have the reagent, for example, CH3Cl in presence of AlCl3, right? This AlCl3 is a Lewis base, whereas amines are your base, and this is a Lewis acid. Sorry, AlCl3 is a Lewis acid. So what happens? There is a reaction between this base and this acid. That is why the reaction does not occur. So this AlCl3 is not able to generate the electrophile from here, because it is involved in the resonance in reaction with NH2. The correct answer for this question is Friedel-Crafts reaction. Very important reasoning question. Okay, next. In the reaction, so here is a series of reaction. We have to find the reagents. Okay, so first of all, NH2 is getting converted to N2Cl minus. So this is your benzene disonium chloride. The reagent for this is NaNO2HCl. So you can see Na, this one is wrong. We can eliminate this option, right, because it is NaNO3. Here we have dilute HCl, here concentrated HCl, so we can eliminate this option also. So option A and B can be there. Now it is BF4 minus is added. So for adding BF4 minus, we need HBF4, right? So this option is also incorrect. Correct answer for this question is option number A. Okay. So after adding this one, you can do this copper with NaNO2 to get you nitro group. Okay. So correct answer for this question is option number A. This type of questions you can easily solve by elimination method. In the carbylamine test, okay, very important test, it is used to predict primary, secondary and tertiary amines. For primary amines, the resulting false smelling product is, so this is due to the formation of isocyanates. Okay, so what is the symbol for this one? We have RNC. So the correct answer for this question will be option number A, CH3NC. And what about this? You know, this primary and secondary amines will show this test, but tertiary amines do not show this test. Okay, next. A secondary amine is, what is the definition of secondary amine? In ammonia, we have 3H group, right? So if any one H is replaced by R group, we call it primary amines. If 2H are replaced by R groups, we call it secondary amines. And if all the 3H are replaced with R groups, we call it tertiary amines. So you can see here, compound with an NH2 group on the carbon atom in the number 2 position. No, this is the meaning here is, suppose this 2 carbon, in the second position we have amine group. This is also a primary amines, it is not correct. A compound in which 2 of the hydrogen of NH3 have been replaced by an organic group. Yes, this is correct. So the correct answer for this question will be option number B. Next. C6H5CH2Cl NH3. So first we can do this reaction. H5CH2Cl, right? So it is converted with ammonia. So this one will be getting C6H5CH2NH2. Okay. Now when you treat it with 2 molecules of methyl chloride, these 2 hydrogens will be replaced. So I will be getting here this compound CH2, N, CH3 and NCH3. So this is a tertiary amine. So you can see the name of the compound NN dimethyl, NN dimethyl. So that part is correct. Here N benzyl and methyl methanamine. This is incorrect. Here phenyl NN. So this is also incorrect. So you can see now these two options, NN dimethyl, N phenyl methanamine, NN dimethyl benzenamine. So if you see, this one is, this phenyl group is attached to this carbon, right? So this part is phenyl methanamine, NN dimethyl phenyl methanamine. Okay, NN dimethyl phenyl methanamine, right? So the correct answer for this question is A. Now benzenamine is not an IUPAC name, so that is also incorrect. Okay, next question. The method by which aniline cannot be prepared is nitration of benzene followed by reduction. So this is correct, NO2 and then SnHCl. This one is a correct method. Degradation of benzamide with bromine in alkaline medium. This is also correct. Reduction of nitrobenzene with hydrogen palladium. This is also correct. Potassium salt of phthalimide treated heat with chlorobenzene followed by hydrolysis with aqueous NaOH solution. So if you have remembered this one, only in this only primary amines can be synthesized by this method, right? There is one step where we add Rx in this Gabriel phthalimide method. There is one, we have this phthalimide, this structure. Now here N minus and K plus is there. So there is one point where this R group attack and forms bond with N. But what happens if this one is a your NeCl, then this bond will not break, right? So that is why aromatic amines, or we can say aniline, cannot be prepared by Gabriel phthalimide method. So the correct answer for this question is option number D. It is only used for preparation of primary amines. Aliphatic, I can write aliphatic primary amines. Next question. A hydrocarbon C4H8 on reaction with HCl gives a compound B, which on reaction with 1 mole of NH2. So okay, we'll go step by step. First there is A. Okay, its formula is C4H8. On reaction with HCl gives a compound B, that is C4H9Cl. Okay, next this compound on reaction with NH3 gives C4H11NH2. Now on treatment with NaO2 and HCl, so this compound should give you one alcohol. Okay, this reaction you must remember, if we have any RNH2 on treatment with HNO or nitrous acid, we get ROH. So the final compound D must be one alcohol group. So the compound D is, so it is very easy to identify. Just see here, this is not an alcohol group. This is one alcohol group, this is one amine group, there is no functional group here. So the correct answer for this question will be option number B, right? Very easy, you just need to know that it has to be an alcohol. So all the other options are different. So whether it is optically active or not, no need to know, right? You already know that it is already one alcohol. So next question, which of the following has the lowest boiling point? So wherever intermolecular forces are less, boiling point will be least. So the lowest intermolecular forces are in ethers. So the correct answer for this question will be option number B. So let us see the next question. We have here NO2. Okay, NO2 is treated with FeBr2 and Br2 in presence of FeBr3. So this reagent is used for bromination, right? So what will happen here? There will be bromination. Now we have SnHCl. So this is used for the reduction of NO2 group. So this NO2 group will be converted to NH2 group. Okay. So very easy till now. Now NaNO2HCl dilute HCl. This is for conversion of benzene disonium chloride. So we will get benzene disonium chloride. Okay. Next we have water warm. See, this is very tricky question. If you don't see this water and warm, you will leave it. So when you warm with water, what will happen? This N2 plus gets converted to OH. So we will get this product as OH and Br. So the correct answer for this question is option number A. Okay, next. Hinsberg reagent is, this is very easy question, Hinsberg reagent is benzene sulfonyl chloride. So correct answer is option number A. Next, which of the following is least soluble in water at 298 Kelvin? Solubility depends on the hydrocarbon chain, okay? If it is more branched, solubility will be less. If it is very big also, solubility will be less. So here, this is tertiary, this is second, this is primary, this is tertiary, secondary. This hydrocarbon part is very big, C6 and H5NH2. So the solubility will be least for aniline. Okay, correct answer will be option number D. So what does factor solubility depends? On size. Okay. Next, if aniline is treated with 1:1 mixture of concentrated nitric acid and concentrated sulfuric acid, para-nitroaniline and meta-nitroaniline are formed nearly in equal amounts. This is due to, okay. So see here, when you treat this one, NO2, okay, you take aniline and you do nitration. Then what is expected? Aniline is a which group? Aniline is a electron donating group, or it is an ortho para activating group. So what we should get? We should find that the nitro product should be in the ortho position, or it can be in the para position, right? The major should be in ortho and para position, right? Now when you do this nitration, this is of aniline. These are the two possible products which we cannot expect that it can give you meta product also. But that strangely we find that in case of this one, aniline, the meta product is having a significant yield in the reaction. So what can be the reason for this? So see here, since this reaction occurs, okay, in a very acidic condition, and this NH2 is basic in nature, it abstracts the proton. Now when it abstracts the proton, what it becomes? NH3 plus, right? Now if NH3 plus is present, it is a meta directing group. So this NH3 plus will direct the incoming nitro group to the meta position. So what happens? See, this is your NH2 which was originally present. Now when you give so much to concentrated nitric acid and concentrated sulfuric acid, the medium is highly acidic. Here NH2 present in the reaction, in the reactant is basic. What it will do? It will abstract the hydrogen. Now when it abstracts the hydrogen, this becomes NH3 plus. Now it is not an electron donating group, rather it behaves as an electron withdrawing group, and it will direct the incoming nitro group to the meta position. Okay, that is the reason why we find meta products also in a significant amount. So the correct answer is protonation of NH2, which causes the deactivation of the benzene ring. Okay, so the correct answer for this question is option number B. Next, the reaction of benzene disonium chloride with aniline is yellow dye. The name of the yellow dye is, this is coupling reaction. If you know, the reaction of NH2 with benzene disonium chloride will give this product, right? So the correct answer for this question will be para-amino azobenzene. This is azobenzene, so it is para-amino azobenzene. One more product we have with phenol group also. Those two coupling reactions are very, very important. Next, which of the following is more basic than aniline? Okay, aniline is less basic because the lone pair of nitrogen is in resonance with the ring, right? Now what is the other? Let us draw the structure. Diphenyl aniline. So we have two phenyl group. Okay, triphenyl aniline. So here we have three phenyl groups. Okay, next we have para-nitroaniline. We have here para-nitroaniline. Okay, then we have benzylamine. Okay, now if you see here, this nitrogen lone pair can donate the electrons. Now in these two cases, this phenyl rings are electron withdrawing group, so they are decreasing the electron density on the nitrogen, so basicity will be decreasing. Here three phenyl groups, so further decrease. Here nitro is an electron withdrawing group, further decrease. But here we have CH2NH2, which is a plus I effect. Okay, so somehow the electron density on nitrogen in benzylamine is more, so basicity will be more for benzylamine. Correct answer will be option number D. Next, which of the following will be more stable disonium salt? So N2 plus, this is your disonium salt. Okay, so this, anything which can neutralize this positive charge will help to stabilize it. So if you see here C6H5N2 plus, there can be resonance here. So the correct answer for this question will be option number B. Okay, next. Gabriel phthalimide synthesis is used in 300. The preparation of primary amines from phthalimide. Which of the following reagent is not used in the process? Okay, so it should be actually which of these used in, sorry, just change this question, is used during the process. Okay, so now you see NaOH can be used, KOH can be used, alkyl halides can also be used. Okay, so the correct answer for this question will be all of this. Just little bit change the question. Which of the following reagent is used during the process? Okay, next question. The correct order of basis nature of the following bases in the aqueous solution. This is a very important question. Just remember this order. It has been asked multiple times in many exams. So first remember, in the aqueous solution, if it is ethyl amine, okay, if the R group is ethyl, then the order is 2 degree, 3 degree, 1 degree and amine group. Okay, now if it is methyl group, okay, then the order will be 2 degree, 1 degree, 3 degree and then ammonia. And if it is gas phase, okay, then the order is 3 degree, 2 degree, 1 degree and then ammonia, right? So anyhow, ammonia has to be at the last for any of the order, but you can see here ammonia is there, here ammonia is present, here ammonia is present. So you can by default change, see that this is the answer. The correct answer for this question is option number D. Now what happens, why this changes in the aqueous phase? This is due to two important effects, that is your hydration, or we can say solvation effect and plus I effect. Okay, the result of two opposing forces gives us something different result. So that is 2 degree will come first. Okay, so now how you can remember, see, 3 is bigger number, ethyl is bigger number. So we can say if a big one is there, then after 2, 3 will come. Methyl is a small compound, so after 2, 1 will come. Okay, this is how you can remember, or any other trick you can use. In the following sequence of reactions, so whenever reactions come, very easy reactions you will be getting. A has undergone reduction to give you B, and B on nitration has given you alcohol. So this is very simple. Which one will undergo reduction in presence of this one to give you NH2? So you must see B must be one amine group, right? B must be amine group, and A to B on reduction we got RNH2, so it has to be a cyanide group. Right? We have studied this RCN. RCN on reduction will give you RCH2NH2. Now here there is a, so nitrile is the correct option, right? So we can eliminate these two. But whether it is propane nitrile or ethane nitrile. So let us try with first propane nitrile. If it is propane nitrile, this is the condition. Okay. Now when you do reduction, what I will get? CH3, CH2, CH2, NH2. Right. Now when you treat it with our nitrous acid, we will get CH3, CH2, CH2, OH. Right. But the question is about ethanol, right? So we cannot take propane nitrile. We have to take ethane nitrile. So if you take ethane nitrile, one carbon will be less. See, this will be here, and here we will get CH2, CH2, NH2. Then here we will get CH2, CH2, CH3, CH2, OH. The correct answer for this question will be option number B. Okay. Now let us see the next question. We have an organic compound A on reduction gives compound B. So whenever you find this A, B type questions, please write the reaction with each of the equation. So we have first A reacting to give you B on reduction. Okay. Then we have which on reaction with trichloromethane. So if we have this trichloromethane, it produces C. Then this C on reduction will give you D. Okay. And D structure, this is N-methyl benzenamine. So this is N-methyl benzenamine. Okay. So this is nitromethane. This option B is nitromethane. Okay. So now you see, if we have benzenamine, so there should be some benzene structure in the reactant itself, right? So from that we can eliminate option B and C. Methanamine and nitromethane, this they cannot produce benzenamine. Now if you see this reaction, first of all, if we take nitromethane, that is NO2, and then we reduce it, we will get, on reduction it will give you NH2. Okay. Now when you treat this one with carbylamine test, it will give you isocyanate, right, NC. And this isocyanate, when you treat it with this catalytic reduction, we will get benzenamine, N-methyl benzenamine, right? So the correct answer for this question will be nitrobenzene. Okay. So the product is benzenamine, so the reactant cannot be benzenamine. So this is also incorrect. Okay. Next question. Which of the following amides will not undergo Hofmann-Bromamide degradation? So you have to remember this primary amines will not undergo, right? So it should have this CONH2 group should be present. So now let us see these options. First is CH3CONHCH3. So we should have this group. For Hofmann-Bromamide degradation, this amine group should be the primary one. It should be NH2 group. But here what has happened? One H is replaced with CH3. So this molecule cannot go Hofmann-Bromamide degradation. Correct answer for this question will be option number A. Okay. Now next question. In the sequence of the following reactions. Okay. So first of all, there is P, then Br2 and SnHCl. So we can check the options once and then we can do this question. So first of all, if we take first option, meta-nitrotoluene. So we have this one, meta-nitrotoluene. Now when Br2 is there, see this one we have to do, bromine will be added to the ring. Nitro group is a meta-directing group and CH3 is an ortho-para-directing group. So you can see nitro group will direct this one to here. Nitro group will direct the bromine to this position because it is meta-directing group. And CH3 will direct either here or here. That is ortho and para position, right? So since nitro group we can say is more dominating, here if we do bromination, this is I am taking option A and checking, okay? So we will get here CH3, here NO2 and here Br, right? So if I am telling, if you cannot identify how to start, you can start with each of the options. Now if you do this NaNO2 and HCl, this one SnHCl reduction is there, this will convert to NH2, then NH2 will get converted to N2 plus and Cl minus. Then when you do H2 and H3PO2, this one will be reduced and we will get this structure CH3Br, right? This structure we will get for R, okay? Now when you do KMnO4, this one will be converted to COOH. But you see this product and this are different. Bromine is not at the ortho position. So what I can say, A cannot be the answer. Now let us try with option number B, okay? So option B is para-nitrotoluene. We have NO2 here and here CH3. Now when you do Br2, now this is more efficiently it can do. See, for CH3 the ortho positions are this one, para position is blocked. For NO2 this is also the meta position. So this reaction will happen more rapidly and we will get NO2 here, CH3 here and this Br will be attached here. So now you see this CH3 was somehow converted to COH, right? So, and these two are ortho to each other. So this can be the answer. If you now treat with SnHCl, this one will get converted to NH2. NaNO2HCl, if you do, this one will be converted to N2 plus and Cl minus. Then when you do water and H3PO2, this one will be removed and here we will get H. So my R in this option B will be CH3 and Br, right? So this is your R. Now if you treat it with KMnO4, oxidation will take place and this is your COOH, right? So we will get COH and Br. So the correct answer for this question will be option number B. So first of all, this is very important question. You have to know all the reagents here and then little identification of which positions the substitution should take place. Okay, now let us go to next question. Again we have a reaction based question. 2-bromopropane is there and it is treated with AgCN. So alcoholic AgCN will convert this one to NC, right? So if you remember, KCN will give you cyanide and AgCN will give you isocyanide. So this is X, okay? Now LiLH4 will reduce this. We will get this one NH and then CH3. So what is the name of this compound? So we have N isopropyl is not a IUPAC name. So we can eliminate that option. Then we have here N-methyl propane 2-amine, right? So N-methyl propane 2-amine. This is suppose 1, 2, 3. On the second position we have this part. So N-methyl propane 2-amine. So the correct answer for this question will be option number B. Okay. Is this clear? N-methyl propane 2-amine. Next. An aromatic compound C7H9N on heating with NaNO2 and HCl forms benzyl alcohol and nitrogen gas. The number of isomers possible for the compound A. So this is very easy question. C7H9 means benzyl alcohol is formed. Means this structure should be like this, right? With NaNO2 and HCl, this one will get converted to N2 plus and Cl minus. Then, with NH2, this will get converted to, this is aliphatic, right? So, aliphatic amines with nitrous acid will give you alcohols. So, my product was this one, which is given in the question, CH2OH. Okay. So, now the question is how many isomers are possible for this one. So, this is little tricky question to find the isomers. So, one we can do is CH2NH2, which is given. This is one isomer. Any other possibility we can check is we can change this NH2 group to different positions and make it like amine group. We can have like this NH2 here, CH3 here. Ortho substitution, meta substitution and para substitution, we can get 3 compounds. Okay. So we have this NH2 and then CH3. Then fourth we can have is NH2 and CH3, right? Now after getting these 4 compounds, the fifth one what we can do is we can take it as secondary amine. We can get this product also here, NHCH3, right? So the correct answer, how many isomers are possible? You have to check all the, this is like a hit and trial method. You have to see all the examples. So the correct answer for this question will be option number A. Okay. Next. The correct sequence of reaction to be performed to convert benzene to metabromoaniline. Very, very important question. Substitution, this is very important. You should know which are ortho-para directing, which are meta-directing, electron donating group, electron withdrawing group. So, few things that we should know is electron donating groups are ortho and para directing. Electron withdrawing groups are meta directing, right? Okay. Now we can check the option. First is nitration. Okay. So if I do first nitration, benzene is there. First we will do nitration, then reduction. Reduction of this one will give you NH2, right? This will give you NH2. Now if you do bromination, bromine will take place at the para position or at the ortho position. We cannot get metabromoaniline because NH2 is an electron donating group and ortho para directing. So this option is incorrect. Okay. Now let us see the next question. First we will do bromination, then nitration and then reduction. So if you do first bromination, okay, see although bromines are electron withdrawing group, but they have minus I effect, but they show plus R effect. Means they are ortho para directing, but the minus I effect is more dominant, but they are ortho para directing. So that means this nitration next if you do, so nitration will either occur in this position or it can occur in this position, right? So in any of the case we will not get metanitrobromine. Metabromoaniline will not be formed. So this option is also incorrect. Now coming to third option, first we will do nitration. First do nitration and then we have to do bromination. Nitro group is electron withdrawing group and hence meta directing. So bromination will take place in this position. Okay. Now if you do reduction, NO2 will be getting converted to NH2. Right. So this is metabromoaniline. So correct answer for this question will be option number C. This type of questions are very common and asked in the exam. So just prepare it. The order you should know. Okay. Next is we have to again find the CH3 MgBr is there, R, dilute NaOH and heat. So whenever there is dilute NaOH and heat, please think about aldol condensation. Okay. And you can see the product is also like this. 4-methyl pent 3En2ONe. So if we do the product first, we have 5 carbons. On the 4th carbon we have methyl group. On the 3rd carbon we have double bond 4-methyl pent 3ene and 2ONe. Right? This is P. Now you have to find R. So if this R is there, okay, so this R can be either one aldehyde or a ketone. So based on this structure, we can say that it must be a ketone. R was a ketone formed. Now from how we can get P, so how we can convert this P to R, which should be a ketone group. And we have been given with a Grignard reagent. So now you see, if this is already one ketone group, so another ketone will not form after doing, if you know we have any carbonyl group, okay, and we do Grignard reagent, we convert it into alcohol group. So this one cannot be there. Ethanamine. Ethanamine, if we have, this does not show any any reaction with Grignard reagent. So this also cannot be the answer. Now if we try ethane nitrile, okay. So if we have this one, ethane nitrile, okay. Now ethane nitrile, if you treat it with benzene, so let us see this reaction. We have ethane nitrile, then you treat it with CH3 MgBr and then OH. So what will be the reactions here? Now in this one is positive, this one is negative. Here this one will be negative, this one will be positive based on the charge. So now this negative part will attach here and the positive part will attach here. So I'll get CH3C, CH3, then we have N plus and then MgBr. Okay. Now when we do hydrolysis, we get this compound. Okay. So from this, so we have got this R group as a ketone group. This one can undergo aldol condensation. Okay, so to get the desired product. So the correct answer for this question will be ethane nitrile. Okay, so it's option C and D. You can type any one because both the options were given same. So it's ethane nitrile is the correct answer. Okay, next. When acetamide is converted to methylamine, what is the name reaction? So this is direct question from name reaction. If we have this one, CH3CONH2 is getting converted to CH3NH2. So in this case, what happens? One carbon group is removed. That happens in Hofmann-Bromamide degradation reaction. So correct answer for this question is option number C. So this is a very important reaction. So learn its application. Whenever there is a carbon is reduced, Hofmann-Bromamide degradation has to be used. Okay, next. Which of the following is the IUPAC name of the chemical in which an ethyl group replaces one of the hydrogen of ammonia? So we have 3 hydrogens in ammonia. One of the hydrogen is replaced with ethyl group. Okay, so this is nothing but your ethanamine, right? So the correct answer for this question is option number A. Next, which of the following statements concerning methylamine is correct? So methylamine structure is CH3NH2. So the first point is methylamine is a stronger base than amine. So basicity depends on the electron density. If there is any group which can increase the electron density, the basicity will increase. So in this case, CH3 has a plus I effect, right? So it will give you, it will donate electrons to the nitrogen and the electron density nitrogen will increase. So basicity will increase. So this statement is correct. But we can check all the other options also. Methylamine is less basic than NHC, that is wrong. Methylamine is strongly acidic. No, because they can, what is the definition of a base? Base is something which can donate electrons, right? So here in case of methylamine also, it will donate electrons. So it is not acidic. Then methylamine forms salts with alkali. No, when it is already basic in nature, it will form salt with acid, not with alkali. So this statement is also incorrect. So the correct answer for this question will be option number A. Okay, next question. Which of the following does not react with Hinsberg reagent? So we know tertiary amines will not react with Hinsberg reagent. So first one is a primary amine, second one is secondary amine, the third one is tertiary amine. This is also primary amine. So the correct answer for this question will be option number C. Okay. Yeah. So these were the top 30 questions from the chapter amines. It is a very high weightage topic. So please prepare all the reactions. If you have any doubt in any question, please comment. We'll be addressing it in our next video. If you have found this video helpful, please like, share and subscribe the channel. Thank you.